All right, hello class. So welcome to 3.1 graphing quadratic equations. We've got two types of equations when we're looking at graphing quadratics. We've got f of x equals ax squared plus bx plus c, and we've got f of x equals a times x minus h squared plus k. Now, the first one, the ABC method, I always call the ABC form. A lot of times you're going to see it referred to as the general form. And then we've got the standard form, which is also the vertex form. And you'll see why in a little bit. In each of these cases, A, B, C, H, and K are real numbers. And this A cannot equal 0 at all. So let's take a look at what these are going to do. So when we're looking at these, which way does it open? In other words, we're looking for its end behavior. It's going to open up. Is it going to open down? That's the question we're asking. So in both forms, if A is a positive number, in other words, it's greater than 0, the parabola is going to open up. If it's less than 0, or it's a negative number, the parabola is going to open down. That's pretty easy to remember. The next question we're going to ask is, where's the vertex? On a vertex, it's either the maximum or it's that minimum of the parabola. So let's take a look. In the standard or our general form, ABC, the vertex, you're going to look at negative b over 2a. Remember, this is our a and our b and our c. This is actually a little teeny part of the quadratic equation where we have that formula and we use the discriminant for something else. This is the part that's not the discriminant. Once we find the x value for that, we're going to put that value into the function and solve for f of x. That's why it says f of negative b over 2a. On the vertex form, it's pretty easy. We find h, we find k, and that's our vertex, which is why it's called the vertex form. Once you have the vertex, it's pretty easy to answer this next question, where is the axis of symmetry? Because it's always going to be the x value of the vertex. It's just going to be x equals whatever that is. So in the ABC form, or the general form, is x equals negative b over 2a. In the vertex form, it's just simply x equals h. One of the other points that we would like to plot is the y-intercept. Now, when we're looking for the y-intercept, that means that we're going to replace the x in each of these equations with a 0. So we're looking for f of 0. It becomes really simple in this one, the f of x equals ax squared plus bx plus c, because when you don't multiply anything by 0, it's going to be 0. So f of 0 is just always going to equal that c. So 0c is our y-intercept. That's not terribly difficult. You have to do a little bit of math when you're going to use the vertex form. So you have a, and then 0 minus h is just going to be negative h. And then you're going to square that, plus k. So that's going to be the y-intercept to 0, and then whatever this value is. All right, and the last question that we're going to ask is, where are the x-intercepts? Now you can find, and remember, x-intercepts are also called things like roots or zeros or solutions. If I ask for any of these things, we're asking for the same thing. That's where the graph crosses the x-axis. And you can find that in a number of ways, and we've looked at those. We can use factoring if it can be factored. We can use the quadratic formula, and we can complete the square. Quadratic and formula and completing the square will always work, whether it's factorable or not. So when the x is intercept is irrational, so sometimes we might get something like 4 or -4 plus or minus the square root of 24/6. We're going to put it in decimal form. So you're going to do that plus and minus thing, and you'll get -1.60 and 0.20, so that you can put these on the graph. That will make it much easier. Now, when the y-x-intercept is imaginary, that means there's no x-intercepts. So if I have a graph and this is my vertex and it opens up, it's going to go like this. It never crosses the x-axis. And so that's why its x-intercepts are imaginary, because they can't be graphed. Or if it's negative, the vertex is down here, something like that.
Okay, so let's take a look at our first example. This first example here, example A, says f of x is equal to -x plus 2x minus 2. First thing I want to do is determine, well, this is written in standard form, so let's determine our A, B, and C. So A is -1, B is 2, and C is -2. So the first thing I want to know is, what way does it open? Well, -1 is our A term, and that is less than 0. So it is going to open down. So when we're graphing that, if it doesn't look like it's opening down, we need to take a look at that. So let's take a look at our vertex. We're going to find our vertex. The x is going to equal -b over 2a. So -b, which will be -2 over 2 times a is -1. So -2 over -2 is going to equal 1. And then we're going to do f of 1 to get our y term. So we're going to have -1 squared plus 2 times 1 minus 2. And so that's -2, I'm sorry, -1 plus 2 minus 2. 2 minus 2 is 0, so it's going to be -1. Oops, there's a negative. So our vertex is going to be 1, -1. Let's go ahead and put that on the graph. So at 1, -1, this is going to be our vertex. Our domain is going to be all real numbers. Our quadratics are always all real numbers. And I know that my range is going to, since this is going down, the top of my range is going to be -1. So it's going to be -1, or negative infinity to -1. This should be a parenthesis, sorry about that. Now our axis of symmetry is always x equals whatever the x value of our vertex is, and so it's x equals 1. So I'm going to give myself a little dashed line to know that that's an axis of symmetry. There we go. When we're looking for the y-intercept, we're going to set f, we're looking for f of 0. So that's going to be -0 squared plus 2 times 0 minus 2. So it's going to be that constant. So it's x, or 0, -2. So 0, -2 is this point right here. And we're always going to have mirror of that too. So our axis of symmetry, we can put a point at negative, or at 2, -2. Our x-intercept is if I wanted to set this equal to 0. Now this one, it does not factor. I could use the quadratic formula. X is equal to -2 plus or minus the square root of 2 squared minus 4 times -1 times -2 all over 2 minus 1. I am going to end up with a negative number because 2 squared minus 4, -8. So 4 minus 8 is going to be negative 4. This is going to be imaginary, so it's 2 imaginary solutions. So, and I also know it's going down. It's not even crossing the x-axis. So that means I'm not going to have any x-intercepts. So I want to graph this, and I know I have these 3 points. Well, what if I want one more point? I could just do something like f of, let's go with negative 1. So negative times negative 1 squared plus 2 times negative 1 minus 2. So that's going to be negative 1 minus 2 minus 2, or negative 5. So I have that point negative 1, negative 5, negative 1, 1, 2, 3, 4, 5 right here, and I'd have its mirrored one. So I'm going to graph this going through those points. And that's, oops, there we go. So you can see all of that, hopefully. And that's the graph for example A. Let's take a look at example B. Example B is written in vertex form. So let's identify the parts of this equation. A is equal to 2. H is equal to negative 2. And K is equal to negative 1. Now since 2 is greater than 0, therefore it is going to open up. Our vertex is HK, and H was negative 2. Oops, I'm moving this all over. Negative 2, and K is negative 1. So let's graph that point, negative 2, negative 1. There's our vertex right there. And since it's opening up, I know this time I'm going to have some x-intercepts. Our domain is always going to be negative infinity to infinity. This range is going to start at negative 1. And since it's going up, it goes to infinity. Our axis of symmetry is always x equals h, or negative 2. So I'm going to put a vertical line at the axis of symmetry. And whatever point I put on one side, I can put a point on the other side as a mirror point. The y-intercept is f of 0. So f of 0 is going to be 2 times 0 plus 2 squared, oops, minus 1. So 0 plus 2 is 2. 2 squared is 4. And we're going to subtract 1. So we have 8 minus 1, or 7. So when x is 0, y is 7. So let's put that point here, right there. And we can do, that's 2 away from the axis of symmetry, so we can go 2 away on the other side, and we'll have that point of negative 4, 7 as well. And then we want our x-intercept, and that is when we set this equal to 0. We have 2x plus 2 squared minus 1. So if I add 1 to each side, and then if I divide by 2, so I'm going to have 1/2 equals x plus 2 squared. I take the square root of each side. I'm going to have plus or minus the square root of 1/2 is equal to x plus 2. And then subtract 2 from each side. To negative 2 plus or minus the square root of 1/2 is what my x-intercepts are going to be. Well, I want to know what those are, so I'm going to use a calculator and put those into decimal approximations. So negative 2 minus the square root of 1/2 is going to be negative 2.7. Remember, that's going to be a point. So negative 2.7 is about there. The other one should be a mirror of this, and when we do negative 2 plus the square root of 1/2, we're going to get negative 1.30. So we'll graph that as well. So let's take this and we're going to connect our points to create our graph of the parabola. Well done.